Hello, I'm Michael Ekstrand, PhD candidate in computer science with Group Lens Research at the University of Minnesota, the lead developer and founder of LensKit. In this video, I'll be walking through an example of using the LensKit Evaluation toolkit to do a recommender evaluation and showing you how to write evaluator scripts. LensKit provides a flexible framework for running offline evaluations of recommender algorithms against datasets. The archetypes that we distribute through Maven, they're basically project templates for Maven, provide examples of this. And this video is going to walk through one of those examples, specifically the fancy archetype that we looked at in the LensKit example walkthrough. That video looked at the example algorithm that it includes, and today we're going to look at the evaluation script. In addition to LensKit, Java, and Maven, these examples also require R and the ggplot2 library for R to generate pretty pictures of the evaluator's output. The LensKit Evaluator runs eval scripts. These scripts, you can think of them like ant build files or make files. They're scripts that define an evaluation, the actions to perform. They're written in a Groovy-based domain-specific language. Don't let that scare you. You don't need to know Groovy well to write them. You can treat them like config files in the simple case or like a custom, slightly weird makefile syntax. But if you do know Groovy, its full power is available to do whatever you want to do in the eval script. You can run these scripts either from the command line using the LensKit eval script that's included in the binary distribution or from a Maven plugin. Scripts have various commands, such as CrossFold to split a data set into individual partitions, or train test to do a train test evaluation on a split data set. Dump graph generates a picture of a recommender configuration so you can debug it. Scripts can also have targets like ant or like make, so you can have the script do many different things and specify what you want it to do from the command line. And the full power of ant is also available through the Groovy ant builder. This syntax is compatible with gant, and it lets you use any ant task, such as make directory or get to download a file over HTTP or unzip to do anything you would do with ant. You can do directly from a LensKit Evaluator script. So let's look at the evaluation script in the fancy archetype to see this in action. So I'm going to start by generating a new project from the fancy archetype using the mvn archetype generate command. And I'll search for LensKit. And I want the fancy analysis, which is number 1. And I want 2.0.1. And now I'll go open my fresh project in IntelliJ. So this project contains the POM, as we saw in the example walkthrough, and it also contains in the source a source directory that has an example algorithm in main, some test code and test, but what we're concerned with in this video, it has the evaluation script under the source eval directory. The evaluation script is this script that's written in our Groovy DSL. We have a lot of imports just like in Java. And we have some variables to make it to better organize our code. Config is an object that's available in your evaluation script that provides access to configuration data from the command line of the runner, from the Maven plugin, to find things like what directory do I want to put the data in? Well, that's the config.datadir directory. And you can also have arbitrary properties in this configuration, which you can get with the get method. Then the first thing it does is it defines a target. Now, this script contains some extra logic that you won't usually have in your own evaluation scripts to handle automatically downloading the MovieLens 100K dataset from the GroupLens webpage. But in the download target, this perform block just means do something. So a target has tasks in it that are going to get run when that target is run. And the perform command just means run a block of Groovy code as a task when this target is run. And then ant tasks are automatically added as tasks to the target. So the first thing it's going to do is it's going to do this check for the MovieLens data license. It's then going to make a directory, get the data set, and unzip it. Just these ant lines, they schedule the corresponding ant task. You can look in the ant documentation for more details on that, to be run when the target is downloaded, or when the target download is run. So the next piece gets into the more interesting things that you're going to be writing in your own evaluation scripts as you use LensKit. We create a CrossFold target that is going to crossfold our data set. And this target requires the download target, so it requires that the data already be available. And then it runs a crossfold command. And the crossfold command takes a source, which is going to be a CSV file that has a delimiter, it's a delimited file. Its delimiter is actually going to be tab. The data goes from 1 to 5 stars with a precision of 1 star. And we're going to put it in train and test files using this name. And the %d is where the name of that fold. We have 5 partitions that we're going to fold the data into. And so it's going to create test1 through test5.csv, and same for train. We're going to hold out, by default, CrossFold splits the users, and then it's going to hold out ratings from each user in a random order. And it's going to hold out 10 ratings from each user. You can also hold out fractions. So I could say hold out fraction 0.2, and it would hold out 20% of each user's ratings. And this, when the crossfold is a task, so when the target is run, the crossfold command, or this crossfold task, is going to be run, and it's going to split u.data from the MovieLens 100K dataset into 5 different train test splits for cross-validation. Then we define the algorithms that we're going to use. And the algorithm method just lets you create an algorithm. It gives it a name, and then the block contains its configuration. These bind commands are just the same bind methods that are on the LensKit configuration method, or LensKit configuration class. And we use Groovy. Groovy has some convenient syntax that lets you omit dots and parentheses and make a very readable, fluent syntax that we bind item score to item score. So we're going to use, this configures an item algorithm, sets up some additional components. We also configure 2 more algorithms. We set up user. We bind the item score to user item score, and configure some additional parameters of that. And finally, we configure the custom algorithm, which is included with the fancy example. We bind item score to extended item user mean score, which is a simple personalized mean item score that's included in this example code. So we define these 3 algorithms. We define them and assign them to variables just so we can reference them both in dumping their configurations to visualization files, and then when we go to actually run the evaluation. We then have a draw target, and that just dumps a graph of the custom extended item user mean recommender to the file extended.dot. This dumps a GraphViz file that you can render with the GraphViz tool to a PNG or an SVG or whatever you want to view it as. Then the evaluate target requires the MovieLens 100K dataset as a prerequisite, and MovieLens 100K, as you'll recall, was defined by a target up here, it was defined as the CrossFold target. So you can assign a target to a variable and then just require that target itself, and LensKit will take it and make sure it gets executed before evaluate. Then we're going to do a train test. You can also, if you have a CrossFold, if you have a target, when the target's run, that makes data automatically available. And so we can just say dataset ML100K, and since the CrossFold command was the last thing in that target, once this CrossFold is run, the data sets that it's available or that are computed from it are automatically available. And so you can just say dataset ML100K, and then it's going to do train tests on all 5 train test data sets that are generated from running the CrossFold. As a convenience, you can just write very simple, you can just say very simple things, and LensKit's evaluator provides a lot of plumbing to get data to the right places. Then we're going to output to eval results. We're going to output the high-level results to a CSV file. We'll also output individual predictions. You could analyze the individual prediction and the rating that was trying to be predicted for each algorithm separately in R or whatever if you want. And we'll also output per-user statistics to the CSV file. And we'll run 3 metrics. We'll run coverage, we'll run RMSE, and we'll run NDCG. And the NDCG predict metric uses NDCG as a rank correlation metric, so it orders the items by, it orders the scored items by prediction, and then computes NDCG using the rating as the utility or the gain, and it sees how good a job the recommender does as putting items in the same order as the user's preference. We're going to run this over our 3 algorithms, item, item, user, user, and extended. Finally, we have the analyze target, and it requires the evaluate target to be run first, and then it uses the ant exec task to run R on our R script, and then we say the default target is analyze. So if we just run the script, it's going to run the analyze target and evaluate and do our analysis. So that's what's going on in this script. You can find more information on LensKit evaluation scripts in our manual, which is linked from the LensKit documentation page. So if you go to the LensKit webpage, you go to documentation, we have a manual. And in the manual, we have some documentation on using the evaluator with examples, more explanations, including information on where to get more information. So to run this evaluation, we can do it either with Maven or with the command line. And I'm going to start by running it with Maven. So we'll just run Maven from IntelliJ. And I'm going to edit the run configurations. And I'm going to add a new Maven configuration. And LensKit provides a Maven plugin to automatically manage running LensKit evaluations from within Maven. And that provides some additional phases in what Maven calls phases for doing LensKit evaluations. So if we say LensKit publish, that's going to run the complete tool chain. It's going to compile our local source code, run the tests. It's then going to run our evaluation. It's going to run the R script on top of it, and then it's finally going to run LaTeX to build a LaTeX document that contains our R script to demonstrate a complete tool chain for documenting LensKit research. So I'm going to start this running. And while it's running, let's look briefly at the R script, and we won't spend much time with it, but it reads in the data, the eval results.csv, and it uses ggplot2 to build plots of the runtime speed and the accuracy using our metrics of the recommender. And the pom.xml defines the Maven pieces, and it has comments in it explaining what's going on, and builds the code. It sets up the LensKit Eval Maven plugin, and it sets it up so that by default it's going to run our eval script, and it's going to both render the visualization of our custom algorithm, and it's going to run the analysis. And then in the LensKit publish phase, it'll use this LaTeX plugin to build a document that contains the charts that we generate. So the evaluation has finished. So let us go look at the results. The results, like usual with Maven, are all in the target directory. And it generated this file, paper.pdf, that contains a citation to the LensKit paper. And it contains our performance charts. So it shows the RMSE of the three algorithms, both using global RMSE and computing RMSE per user and averaging that. And it shows item doing the best, followed by user, followed by the personalized mean. And also shows the NDCG of those algorithms. And we get some nice box plots of how long it took to build the model for each algorithm. User doesn't really have a model. And the personalized mean model is very fast. And then the time it takes at runtime to generate all the test predictions. So you can see how the runtime performance of the different algorithms is compared. Also in the analysis directory, we have the accuracy and speed charts themselves, as well as the GraphViz file. And I'm going to draw that GraphViz file quick, so we can see what one of these diagrams looks like. So it shows first the root, which is just a placeholder that provides a beginning for the diagram. It shows that the root depends on, so just a plain arrow is depends on, a top-end item recommender, a rating predictor, a global item recommender. These are all provided by default providers in LensKit that automatically provide sensible versions, so a top-end recommender, a simple rating predictor, a global item recommender. And the interesting thing, several of those and the root itself depend on the item score, which is provided by our extended item user mean item score. This is the custom algorithm that we have in here. And it depends on a user event DAO. So it has these fields. These show basically its dependencies. And then they have lines going to the thing that satisfies them. So the user event DAO is provided by the prefetching one. The item mean model is provided by the item mean model, and the mean damping parameter is just 0. The item mean model is provided by the item mean model builder. This kind of an arrow means provides. And then that builder depends on a DAO, an event DAO, and it has a parameter. And the prefetching user event DAO also depends on an event DAO. And the prefetching user event DAO is just the simple user event DAO. The user event DAO provides you access to events by user. So you can say, give me all of this user's ratings. And it just depends on an event DAO. An event DAO gives you all the ratings in the system. It just loads them all up into memory, indexes them by user, and stores that in memory, which for doing offline evaluations is often what you want. So these kinds of diagrams let you see what your recommender configuration looks like and look for places where you might want to change it. There's not a lot to change in this one, but you could use, for the The rating predictor, for example, you could use a different baseline score, or you could reconfigure the preference domain. Thank you for your time, and I hope you found this useful for understanding the LensKit Evaluator. We look forward to seeing your research, and